Hello everyone, I am Mohan Karthik, a member of Team Mavericks. This presentation gives you an overview of the project we have been working on, which involves the integration of vision-based robot manipulation utilizing ROS for assistive applications. So what exactly is our project about? Basically, it comprises deploying a manipulator to do assistive related tasks. It employs cameras and computer vision algorithms to understand its environment and decide how to interact with objects. Overall, this project has the potential to improve people's quality of life by providing automation. We divided the work process into two phases. The first phase consists of building the unmanned ground vehicle, which is the UGV, configuring a Jetson Nano, operating the UGV using MAVROS, and integrating a robotic arm to the UGV. A pre-existing robotic base is used to build the UGV platform. The UGV we are building is a 6-wheel drive rover with a skid steering mechanism. We have added an aluminium molded structure on the top to withstand more weight. Parts used in the UGV are Pixoc. We used Pixoc 2.4.8, which is an open source autopilot system. It works with sensors like GPS, IMU, encoders, and other environmental sensors to collect information on the rover's position, orientation, and surroundings. Pixoc software, which commonly runs the Ardu rover firmware, enables rovers to navigate autonomously, avoid obstacles, follow waypoints, and plan missions. Next comes the Sabertooth. We utilized Sabertooth 2x12 motor controller, which delivers a 12 amp output to the motors. It is used to regulate the speed and direction of the DC motors. Next comes the GPS module. We utilized the GPS module to determine the specific location, velocity, and time of the UGV. Next is the 3DR radio transmitter. The 3DR radio telemetry kit establishes a wireless communication link between a ground station and the UGV. It is a trans-receiver module set that permits bidirectional connectivity for telemetry data and command transmission. Next is the Jetson Nano. The Jetson Nano is an entry-level embedded computing platform developed by NVIDIA. We have used it because its GPU accelerated computing allows efficient execution of the computer vision algorithm and can also handle complex image processing tasks. We then set up the Jetson Nano by installing Ubuntu 18.4.6 and downloaded ROS and MAVROS into it. We programmed the UGV to move it in a square shape. For the development and controlling the robot system, we are using ROS, which is Robot Operating System. It is an open source framework for developing software for robots and robotic systems. It provides a collection of software libraries, tools, and conventions that help us to create robot applications. It supports multiple programming languages, including C++ and Python. We then used MAVROS, which is Mavlink, and ROS, which is a middleware that provides communication between Mavlink-based autopilot, which in our case is Pixoc, and ROS-based systems. MAVROS provides a set of ROS packages that allows ROS nodes to communicate with Pixoc using the Mavlink protocol and also to send and receive commands and data to and from the autopilot. We then built the robotic arm from a pre-existing DIY kit and integrated it to the UGV. The robotic arm we built is a 6 degrees of freedom . With this, we have completed the phase 1 of our project. Phase 2 of the project consists of GPU-based object detection using Jetson Nano, development of vision system which we have planned to do using Raspberry Camera V2, development of indoor navigation system using LiDAR mapping, and finally, planned on designing a GUI using Qt and Python. The current status of the project is shown in the video.